Thanks, Julie. So just a warm welcome to everyone that we've got attending this evening's talk here. I'm sure we're in for a really exciting time. For those of you who don't know me, my name's Cara Lang. I am the GM of Enterprise Risk Management at Oman. And so for those that are members, I have joined the WhatsApp group. I've been in Oman for around about the last 6 months, but it would be great to also be able to touch base with you risk management professionals that are out there and start getting a good community going where we can share risk information. So in light of that, I would like to introduce our speaker that we have this evening. It is Captain Fahad Ibn Masood. Forgive any of my pronunciation errors that I might still be battling with since I've joined. But Captain Fahad comes to us. He's an international safety specialist who has spoken on various international forums on aspects of safety risk management. He's an ex-military fighter pilot, well-versed in various domains of hazard identification and risk assessment. And so he's really a been there, done that on a tactical level, as well as on operationalized various concepts of human factor and occurrence investigation. He's trained both nationally and internationally, delivering talks, papers, and generating discussions in countries like Iceland, the UK, Singapore, Australia, here in Oman, UAE, and Pakistan, with a cross-section of audiences from corporate, civilians, academics, and the military. He's made more than 100 televised appearances, and is a certified accident investigator from the Embry-Riddle University in the USA. He's an active member of the Royal Aeronautical Society in the UK, as well as an International Society of Air Safety and Investigators from the USA. So no doubt he has a wealth of experience to be able to share with us today, specifically on the topics of, I think, safety, but I think he's got some other areas that he's probably going to look at from as well. So without further ado, over to you, Captain Fahad. Thank you for joining us this evening.
So very kind, Ms. Cara, and it's a pleasure being here for speaking on this very innocuous subject. And we have a lot of things on the card right now, but very limited time. And for that, I have construed my slides to a limited of about 20. So won't be having too much time spending on a monologue where I am the only speaker. My aim is to add value to you as professionals, may it be on the risk management side in any HRO, which is a high reliability organization, as well as a part of the ultra safe high risk industry. So no matter where you are, I believe what I'm going to share with you, with my background in aviation, will hold value to you and for your future growth, because where we stand today is all to do with risk management and the all important aspects of growth. We need to understand a few prerequisites before we move ahead. First and foremost, a lot of people confuse between hazards and risks and what comes first and what comes second. So hazard is always one. I always take it in the alphabetical order, and risks come subsequently as a result of a hazard. So we'll talk on these aspects and a few more as we flow through the program. Over the previous few years, we have seen a huge jump, if not a quantum jump, on aspects of data. This data relates to all real-time information that is at present available in zotabytes of information, and we'll talk of zotabytes as well. Previously, it was all about pinging data from aircrafts halfway across the world to headquarters, may it be Boeing, Embraer, Airbus, or any other aircraft for that matter. But things have changed, and changed for the better. I would take you back to this loss that we had with the MH370, the Malaysian aircraft, which till date has not been found. It still remains a mystery, but things are moving towards the correct in the correct direction. A brief entree to myself. to add to what Ms. Cara had said. So I've been there, done that on a few fronts, if not many. I hold at present a CPL in aviation, or being a pilot side. I am a risk manager within a high reliability organization as well. The latest assignment which I'm holding as I speak to you now is a faculty at the Modern College of Business and Science in Muscat, Oman, where I facilitate learning for bachelor students in both aviation management and airport management programs. I am trained the trainer profile in the CRM domain. This is a lot to do with human factors. I have experiences of a few fatal air crashes that have taken place over the past few years as well. So enough said on me. Let's move to the crux of the matter. We relate the information of risk management to culture, and with culture of safety. If we go through the ladder and the image that you see on the screen, you will certainly see there is increase of information as the ladder goes up, and on the right side you have increasing trust and accountability. This directly relates to the SMS in HRO. SMS stands for Safety Management System, for all the newbies who are there, just like me, who are less experienced as well. So the maturity of an SMS relates to these steps that are mentioned, starting from pathological to reactive to calculative, proactive, and last but not the least, which is the predictive element, where we want our organizations to be at, so that we are able to mitigate risks as far and wide as possible. We will not be going into intricate detail of predictive modeling. That is beyond the scope of today's lecture, but maybe in the subsequent discussions we will head out there as well. We've talked on SMS, or safety management systems maturity. If we go into the first domain, it's basically in relation to something that has already happened. So as the word goes, reactive, it's all to do with something that's happened in the past. Proactive relates to something which is actively identifying the hazards. And something that is on the cards for today, which is the predictive, which is also future, relates to future problems. A lot of professional risk managers also have challenges in differentiating a proactive from a reactive safety management strategy. So the biggest difference, which I can tell you, is proactive is all in relation to an accident data that is available to us, and we make or generate a trend from it. On the predictive side, we have anything and everything that we have in normal operations. I would also relate this to any healthcare or health management system. If we have everything going happy hunky-dory, it does not mean that an accident or an occurrence or an incident cannot take place. It may or may not. That will all determine on how well do we utilize the predictive methods of finding trends out of normal operations. So that is where it stands. If you look at this next slide, and I would like to explain this a bit, we have greater exposure on the left-hand side and least exposure on the right. We're looking at hazards which are gradually moving through the system of SMS, and the reduction in risk. So the activities in the reactive profile relate to inspections, FOD in aviation, pardon for that verbiage, but FOD stands for foreign object damage. We have accident responses. As we've discussed, it is in after an accident takes place. Corrective actions, pardon me for looking there because I have a big screen that side. So checklist actions, which are ideal both in aviation and any other HRO. If you go to civil nuclear technology, they have their own checklist of actions which are critical for operations to be on spot every time. And then we have accident reporting methods. Obviously, we're looking at accident trends and rules and regulations which help in the process. Second tier relates to the proactive side, where we have an increase in safety efficiency. We continue to move ahead. Exposure is reducing. The risk associated to that hazard or that scenario is also reducing. And we have activities like the gap analysis, the advisory circulars, or the ACs as we call in US. Increased awareness, FOD detection. Mind you, if you can see the difference here, we have FOD detection here, and in the previous we had FOD response. So once again, reactive and a proactive domain of understanding there. So what is more important or critical for us to understand here is further reduction of risk. A lot of professionals, once again, relate this to being a stepwise or an improvement of the SMS system itself. But if we look at the overall picture of it, there is no seam in between. It's all seamless improvement or continuous improvement of the SMS. As we saw in the previous slides, it all relates to the maturity of an SMS. And that is where the truth lies. And if we look at the last section, where we have further reduced we have further introduced our expanded controls right here. If we look at this readout, and we have a reduction in risk, further great improvement of safety efficiency, and in turn we have reduction in exposure. If you see, what we're doing here is hazard exposure which was available or which was there in the system has been reduced to the best possible. We all understand all systems that are there depend on human factor, because no matter where we go within the organization, starting from the strategic, operational to the tactical tier, we always have the human element there. Hence, if you see, there is not a match between the risk as well as the safety efficiency. That means risk management can never, well, not at least till now. Let's wait for the next chat GPT or the chat AI bots that are coming across. Maybe they do something better. But for now, we cannot mitigate our risk associated to a hazard to zero. It will be taking its due time. It will take due diligence, as the phrase goes. Hopping on to the next slide, let's have a few broad differences between the three elements: reactive, proactive, and predictive. If you look at the buzzwords here, we have actions, we have response. This is the reactive mode. Second, we have proactive, where we again have actions, but we are looking at perceptions or perceiving the hazards that are related to an accident or something that has happened before. Let's move on to the predictive, which is the crux today. Actions, once again, it is all about forecasting future and the potential hazards and risks. This is how we segregate the three in case of definitions only. The management activity, once again, the buzzwords here is after, where post haste, before in case of proactive, and analysis in case of predictive risk management. Analysis of normal operations. This is what we need to have an understanding of in predictive side. If we look at the primary frontline employee, in case of the reactive, and these are the guys who literally get their hands dirty, are looking at actions to prevent risk occurrence. They are mitigating damages. They have an accident, God forbid, and occurrence taking place, and they act in a reactive mode. Then into the hazard mechanism and threat identification. This has been a part of aviation, because I can speak out of my own experience, as the format of CRM If we go to CRM version 6, which is the latest version right now, that relates to threat and error management, threats from outside the cockpit and errors from inside, because we have the pilots inside, human factor once again. So that is where it stands. Moving on, predictive doesn't have anything right now, so we won't divulge there. A few examples: specific aviation, we have the MORs, which is the mandatory occurrence reports, incident reports, accident reports, which relate to the reactive side. If we go to the proactive element, we have audits, which is once again a very effective way, if done in true letter and spirit, to reduce or mitigate the risks associated to aviation or any HRO domain. Voluntary reporting, NASA came up with this in the 80s. It's been a very, very successful and they method, and they've kept it anonymous as well. Surveys, once again, is important. But this is where we stand. We need to have a system analysis. This relates to change management within the organization, or within the way the system or the company or the organization is working. We're looking at safety cases, learning from other people's experiences or negative consequences that have occurred. FDA and FDM both are valid, especially in the aviation domain, because FDA is flight data analysis and FDM is flight data management. Both are important because they are all normal operations data, which is processed and converted into information. And to completely close the loop on risk management, I cannot give you a number, it is that big. An analysis tool which enables safe operations, or has enabled safe operations on a global scale in every possible domain of commercial as well as military operations. So it's very wise. Life is all a matter of perspective and perception. You see it one way, you see it the other. The London Eye looks gorgeous both ways, but for a guy who's stuck there right at the top with no electricity and God forbid a complete blackout, for him or her, this is not the best place to be. This is why I want to put this here. Predictive aviation risk management ensures that we don't get stuck right there at the top at the wrong moment. Let's head on to our alma mater, which is ICAO. For all those non-aviators, ICAO stands for International Civil Aviation Organization, which regulates aviation on a global scale. We call it the ICAO GASP, which is what I'm introducing to you right now, because it relates to predictive aviation risk management. And the Global Aviation Safety Plan states a few important things. One is the technical capabilities required for the human capacity building and competencies that is there. There needs to be investment, and investment is not only in relation to finance, it also relates to time. These technical systems have to continue to evolve. The AI, the ML, the modeling, predictive modeling specifically, needs to continue to evolve so that we make it better and improve in the process. We need to have HR, or human resource, human capital, which is informed, which is competent in domains more than one. We need to, once again, analysis is a buzzword here. Various forms of safety data is available. Previously, the challenge of generations before the IoT of things, or Internet of Things as we call it, was that there was limited data. They did not have too much to play around with, but now things have changed and improved. And in the process, we have a lot of data available to us from where we can learn through analysis of what can go wrong in the future. In aviation and in all HROs, we continue to harp this tune. If everything is going well, don't think it will continue that way. keep a watch out for any and every possible indicator of what can go wrong. And if you intervene or you generate the intervention right there and then, the all important James Reason Swiss cheese model or the domino effect, that theory that we have, can be stopped at the very onset, even before the process sets in. So mitigation strategies here, we understand the word mitigation is all to do with reduction. We always can reduce the overall errors to a minimum possible, but never to a zero, because the human element is always involved. Multiple data sources, yes, as I mentioned before, we have a lot of data. We need to look at the predictive risk management side, and that is what the ICAO Global Aviation Safety Plan also determines and tells us for the future. A quick calculation. This is an aircraft which is flying across the United States from New York to Los Angeles. The flight is about 6 hours of total. It's a twin engine 737 Boeing aircraft. Each engine during this flight time will generate a whopping 20 terabyte of data. And if we look at the number of flights that take place, it's about 30 odd thousand, give or take a few, and it does it every day. And that's how it goes. If you multiply all this, it comes to a even bigger whopping number of about 2.9 2,499 billion terabytes. And I did mention we'll talk about bytes in the later part. So if I were to tell you the biggest number that we have in bytes is called yotta bytes. It's YOTTA. It relates to about 1204 zettabytes. Zettabytes is 1024 exabytes, and exabyte is 1024 petabytes. These all bytes, majority of us, including myself, before I went into this predictive aviation risk management domain, did not have any idea, and probably a few of you also don't. Now we come into the gigabytes that or terabytes that we've come across. So 1 petabyte is 1024 terabytes, and 1 terabyte is 1024 gigabyte, and everything else goes smaller as we go through the process. My point to bring home, the data that we have right now is immense, and that is what is called big data. Predictive aviation risk management requires this big data or immense amount of data that is churned out of this one aircraft only, a 6-hour flight. And like these, there are hundreds, if not thousands, of aircrafts which are flying at the same time in the air. A few basic important 7 V's of the big data, where velocity, the speed of data is important. We've got the volume, amount of data, the variety, different types, variability, quality of data, we have the veracity, then the visualization, which is done through modeling. The value is immense of this data, and it goes through the process. We convert, as I mentioned before, data into information through a process. If we churn it through a system, which is the modeling that we call, it really makes a mark. Once again, coming back to the GASP, or the Global Aviation Safety Plan, as I had mentioned before, we require multiple data sources, which we have. We add this with the safety data that's already available because of all the occurrences taken place previously. We add on the capability of technicalities, may it be data scientists or machine learning specialists and professionals or AI specialists, and they come up with their knowledge and skill to enhance and get this predictive aviation risk management on the road. This is, mind you, the most effective strategies for mitigation of risk. I would not call this an overstatement once I say that this is the only future that we have. because the quantum of flying is continuing to increase as we go in the post-COVID situation. And if we don't latch or hold or catch the train, as we call it, of predictive risk management, we may be a bit too late, and the accident rate will rise and the occurrences will start to creep in. It's not that we are not, but we need to be precautious of this fact that this is the future and the way forward. A few contents: we have data, we have techniques which include, as I mentioned, processing, analysis, modeling, visualization, and this relates to our flight data monitoring in case of aviation or monitoring overall. And then we go into the predictive aspects. There are a few applications which relate to this. There is a humongous amount of information available on the World Wide Web as well. Once again, this was supposed to be a dialogue, but I'll push this question to myself. And the most important function of big data, which relates to predictive risk management, excuse me, is all to do with data-driven everything. There's something called as D3M, data-driven decision-making, excuse me, in aviation. And then we have the all-important machine learning. We also have visualization in the case of modeling of this data. Data and risk modeling give us a very clear risk picture. Just a quick background. Risk management was initiated from the financial side. That is where it started from. But things have not stopped from that point onwards. We have continued to evolve this system into every possible high reliability or a high risk organization. Right, let's, yeah, well, no show of hands there because we're a monologue. So I'll read the question myself. So the aircraft sensor data, maintenance data, and operational data, once again, these are all data, has grown to the point of exceeding most aviation companies' ability to efficiently and effectively improve business processes and outcomes. Do we agree or not agree? Let's go to the next slide. The survey that was conducted by airline and MRO executives, 73.4% of aviation professionals agreed that there is so much of data available that it is near impossible, as I mentioned, I'll reiterate, near impossible to salvage all the data at the same time. The processing power of computers, even with all the Moore laws being applied, where we have computing power doubling every fiscal year, it is still not enough to harness the power of data. I wouldn't hold myself back by saying data is literally God right now. If you have the data and you're able to crunch the numbers correctly, and you have the capability to analyze data correctly, you are the boss of any and every domain. You have market intelligence, you have information intelligence, and every other type of intel that is there. So a few quick software options available for this purpose of data analytics. Boeing has its own, Skywise with Airbus, eFast with Pratt and Whitney, Spark, Apache, Data Torrent, Google BigQuery, Hadoop, which was old school, now it's Apache Storm. So it's a never-ending process, to be very candid. It's a thing that is an ongoing, continuous thing which doesn't stop. Because I want to make this an interactive session and take your questions, so a quick summary. We have data. All data is available in the form of FDM, which is flight data management. We've got the flight paths, which are there in aviation, the occurrences that have taken place before, the weather phenomena which are there. A few techniques relate to the IT infrastructure and everything that is written there. Visualization, once again, is the key, because we use the modeling aspects to do this. The applications are innumerable. We cannot go into anything else but without the use of data in case of predictive aviation risk management. So indicators is key. This tells the managers or the upper tier management that there is a possibility of something that can go wrong, and we don't want things to go wrong. We need things to go right, and that is why the strategic tier is continuously looking at the predictive aviation risk management side. And all this, as I've mentioned with the GASP, if we connect this, we have multiple data sources, various forms of safety data. We have the technical know-how, the technology that is there, the professionals which are both on the engineering, the technical, and the pilot side. And last but not the least, we dovetail all four and we bring in the predictive aviation risk management domain, which I'll reharp is the most effective risk mitigation strategy around the world. Second last slide. So with the passage of time and with the increase of data, we have moved from descriptive to predictive to prescriptive, and this is where we want to be. This is where the AI or the machine learning is going to take us. Cognitive is all to do with our own mind. Neural learning or machine learning, how does the brain intake information, our mind, and how does the artificial intelligence mind take the same information? You probably have seen this movie Stealth. If you haven't, go ahead and have a watch. The AI that is there in one of the aircraft does wonders. Yes, it has glitches just like any other system, but it can mature into something a lot better. Rest assured, predictive aviation risk management is the future of aviation. This brings me to my culmination slide of information which is there on the slide. You have my email address, you have my WhatsApp number. You can contact me from anywhere across the globe. I'm one of the extroverts, I guess. That's what I call myself. And you have my LinkedIn address as well. That brings me to the end of my part of the discussion or the talk I wanted to give and the information I wanted to share with you. That is all from my side. The house is open for questions.
Thank you for that great presentation. We do have a couple of questions. So the first one is from a member in Pakistan who I think is having problems with his internet connection, but he said he's managed to grasp some understanding of the concept. Great presentation as always. So he's got a question on the apps that we can install on our mobiles like Flight Radar and ATC online. Do they have any connection to the data analysis, in brackets, predictive capability and risk management?
Absolutely. This data that is coming to us is through the ADS-B or the automated dependent surveillance broadcast of aircrafts. This is live data. And if you can well imagine this Flight Aware or Flight 24 or these apps which are available, if they have access to this information, which is open source, how much statistical information is available to the players in the industry, not to take names, but it is a wealth of data available, and it does affect, influence, improve risk management, which was previously flight safety, in domains more ways than one, on operations as well as maintenance.
Great, thank you. That's a really comprehensive answer. Then we've got a question from Issa. What is the most efficient strategy to analyze data, please?
Okay, so as I mentioned before, this is beyond the scope, but predictive modeling has two basic. One is machine learning, the other is AI. I would rather recommend that we take it to our next session when we have it, and I'll have a detailed answer. But in the short way of putting this, there are a lot of open source softwares which process this data into information and in the end into visualization to enable data-driven decision making. So that is, I guess, sufficient for now.
Thank you. That's a really difficult question to ask in a short amount of time. That's all the questions I have here. Kara, do you have any questions for Captain Fahad?
Thanks, Julie, and thanks, Captain Fahad. I mean, I think bizarrely enough, I actually spent some of my career in aviation. I used to work in the internal audit side from South African Airways, and did some work as well with some of the Middle Eastern airlines. And so I guess I had always looked at it from an enterprise risk management perspective. And obviously, although you've spoken about aviation today, but prediction in terms of risk management is applicable, whether it's aviation or whether it's telcos. And I think maybe one of the questions that I'd wanted to ask, just from the aviation side. So where would this department sit? Does it sit in operations? Does it sit in a risk management? And I mean, I guess if there's any, kind of risk people that are on the call that work in the aviation sector now, who do they go and have this conversation, with?
Okay, so the operations side has this department of sub-department called the FDM, or the Flight Data Management Department, or which is doing flight data analysis. Any and every flight that is taking off and landing has a specific set of information that is stored in the flight data recorder of the aircraft, or the FDR. Sometimes we call it the FDCVR. This data is decoded by the department and looks at what envelope is being pushed by pilots or flight deck managers on flying the aircraft. That is one. On the other side, we have the airworthiness, which is looking at the maintenance side, the engines. As I mentioned, the 737 was generating 20 terabytes of data over a single hour. That's a lot of data. And present time, this data is streamed globally, not pinged in packets as it was before. So there is, as I mentioned, humongous amount of data, both with operations in an airline or operations department, as well as the airworthiness, which is the flight engineering side.
No, thanks for that. I also think, risk professionals are very good at doing the what could go wrong. And sometimes I think we also have to apply that lens, because you'll have the data scientists and you'll have them, but they don't necessarily, put that predictive element, I think, to it, which I think is, which is where, as risk professionals, it's our responsibility as well to be able to step in and work out how we can incorporate this into our risk management practices. But yeah, that's the question from my side. Thanks, Julie.
Great, thank you. I have had another couple of questions. There's two questions, both from Masood. So the first question is, what is the next improvement in PRM? And the second question is, which airline is the best in PRM and why, in your opinion, that is?
Okay, so statistics speak for themselves. Predictive aviation risk management overall has seen growth globally. But if we call any country or any state at the leading edge of this risk management, I would take this as Australia. The CASA, which is there, is really good at doing or focusing on predictive modeling on this. So that is there. On the airline front, if we look at numbers, we have had very limited occurrences taking place globally, so we cannot put a finger on it. But if we look at the aerospace side or the aircraft manufacturing side, then ATR, which is the subsidiary of Airbus, which was recently acquired, not recently, sometime back, but anyway, so ATR takes the cake, if I were to put it that way, in predictive modeling and risk management, because their numbers are marked difference than what Airbus may be on the defense side, or Boeing may be on that military side, have been able to generate over the previous few years. So ATR is for me number one.
Great, thank you. So that's all the questions. Cara, do you have any closing comments before I bid everyone a good evening and thank Captain Fahad?
No, I think just a big thank you from my side. As I said, you know, we might have spoken about aviation today, but it's something that's so relevant across all of the industries and what we need to be doing from a predictive element. We can't just be, I guess, doing our risk registers with our risk champions and going through a series of questions of what keeps you awake at night, you know, these types of things, which are sometimes, you know, what we can slip into, as well as, you know, to your point, looking at, you know, the big drive after COVID was like, oh, you know, what lessons did we learn? How can we put those in? Unfortunately, I think this aspect of predictive analysis and incorporating that into our risk management practices is absolutely critical. And so I think, you know, this talk was just completely invaluable, and you know, obviously it grows from here, right? When we start getting into the nitty-gritty of what that looks like, and from a modeling and an AI perspective. And so I think it's something that we can obviously grow. So just a huge thank you from our side, and from everybody I think that's on the call. And yes, we look forward to exploring this discussion further.
Pleasure being here.
Great, thank you, Cara, and thank you, Captain Fahad, for that really interesting webinar. I'd like to wish everyone a good evening and to let you know that the recording will be uploaded onto the IIRSM YouTube channel in the next day or two, and your attendance certificates will come out this time tomorrow. So good evening, everyone, and thank you for listening.
Take care, everyone. Bye. Cheers.
Take care.